back to my channel. So we'll continue with homogeneous first order equations. Then we'll move to reduction to homogeneous first order equations, after which we'll see how far we can go. What are homogeneous first order equations? If we have a differential equation, dy by dx is equal to a function of x and y divided by another function of x and y. If I can divide through by 1 over x raised to power n and have it both up and down, and this equation changes to a function of 1 comma y over x, n of 1 comma y over x, then, so this is what I mean. If I have a function of x and y, and I have another function of x and y at the denominator, if I can multiply, this is the same as multiplying through by 1. This becomes a function of 1 comma y over x, then it is homogeneous. If I'm still going to see x inside, it is not homogeneous. If I still see x alone or y alone, it's not homogeneous. Let me give some examples. So if we have something like this, the y by dx is equals to x cubed y plus x squared over x squared y squared plus x cubed y. So then is the highest power of, when I multiply x and y, this is 3 plus 1, 4. So I will multiply through by 1 over x raised to power 4. Multiply through by 1 over x raised to power 4. This will give me y over x plus x raised to power 2 over x raised to power 4. That's 1 over x raised to x, 1 over x squared. And then this is divided by, I'm multiplying through by 1 over x raised to power 4. So this is just y squared over x squared. So I can just say y over x all squared. And then this is the same thing as what y over x. Yeah. This time is just plus y over x. Now, is this homogeneous?
No.
Huh? What do you think? Is it homogeneous?
No.
Why?
Because that the 1 over x squared is just.
This is a function of 1 over x squared comma y over x. It's not 1. While this one is a function of, you can say 1, because 1 is like something times 1, okay? 1 comma y over x. So because of this 1 over x squared in the numerator, it is not homogeneous. So usually, when you see an equation that is homogeneous, the multiplication of both of them on every part will have the same power. Like the sum of this power, sum of this will have the same power. If there is one that is lower or higher than the rest when you multiply x and y together and sum their powers together, then it's not homogeneous. Let me give you an example of one that is homogeneous. So, if I sum their powers, I have 3, 3, 3, 3. I can already see that it's homogeneous, but if I want to check, I'll multiply it through by 1 over x raised to power 3, both the numerator and the denominator. And this will give me y over x squared plus 1 all over y over x cubed plus y over x. What we can see here is that this is a function, the top is a function of 1 comma y over x. Are you seeing it? And then the bottom is a function of You can still say 1 comma y over x, okay? 1 comma y over x. Even if I had maybe 3 times x squared, this is 3. This is still 3 times 1. It is still homogeneous. Okay? Do you understand? Because it's a constant. Okay? That's a constant coefficient. Now to solve homogeneous first order equation,